Welcome to OSDU Data Platform Application Developer Training. In this presentation, I'm going to speak about the Schema Service. This service deals with the data schema lifecycle. A schema is a data model definition. A data model describes the structure of a system, that is, the entities and relationships between them. The OSDU data model is defined in rich JSON object as per the JSON schema specification draft number 7. Every schema in the model is uniquely identified and semantically versioned. The identifier has 4 sections separated by columns. The first section is the authority, which is the authority defining, managing the schema. The second one is the source from the data of the given schema is expected. Third section is the entity type for which the schema is being defined. The last one contains the major, minor, and patch version that allow the semantic versioning. For example, the following ID has OpenDES as authority, WKS as source, master data well as entity type, and version 1.0.0. In the system, a schema is scoped in either way: internal, which means it is available only within the single partition, or shared, available to all partitions. The Schema Service enables centralized governance and management of schemas in the OSDU ecosystem. In other words, it allows the control of the schema's lifecycle and its validity status. For this, it provides all the necessary APIs to fetch, create, update a schema, or mark it obsolete. In order to be able to perform all these operations, you need to have the Service Schema Service Admin permission. To learn more about permissions and groups, watch the entitlements presentation. Additionally, a schema has one of these 3 states. It could be in development, published, or obsolete. Whenever a schema is created in the system, it can be set as either development or published state. The main difference between these 2 states is mutability. Once in published state, the schema is immutable and cannot change its state. In contrast, when a development state, the schema can be updated and moved to either published or obsolete states. In this slide, you can see an example of schema definition for an entity, specifically for seismic processing project. This helps to illustrate some ideas. The JSON schema draft number 7 allows using schema references to other schema definitions. In this manner, we can reuse existing schema definitions to create more complex schemas. For instance, in this example, you can see 2 references, abstract master and abstract project, which should be already defined. Below, there is a definition of all properties of this entity. I will elaborate on these types of schemas, including abstract types, a little further. During schema creation, Schema Service resolves all the reference schema fragments and creates a completely resolved schema. This is an example of a schema record. Here, you can see the previously mentioned properties forming the schema identity like authority, source, entity type, and semantic version. There is also the scope and the state of the schema, and a special property named schema, which is the schema definition itself. When creating a schema, the service resolves all the reference schema fragments and creates a completely resolved schema. Schemas allow to define the OSDU data model. Every entity in the model is described by its schema. This diagram shows a simplified view of some entities you may find in Manifest. The OSDU data model is governed by the data definition team. The types and its relationships are described in the data definition repository. The OSDU data model is described as a hierarchy of entities. For instance, manifest could contain master data, reference data, and data which in turn contain work product components and datasets. Every entity can be composed of one or more abstract entities. In this example, the abstract entities are ACLs or ACLs, legal, and so on. The colored boxes represent kind, and to the right, you can see the examples. This is an entity relationship diagram. It shows the generic entities and its relationships within a manifest. The boxes represent entities. For instance, the yellow ones are master data, the blue ones are abstract entities, and the green one represents reference data. Every entity is described by its own schema. The arrows represent relationships between them and the cardinality. As previously mentioned, every entity is described by a schema. Now I'm going to demonstrate you several examples of the schema APIs. Here are 4 requests. First, I will show you how to create a schema. Here in the body, there is the schema record, the property describing the schema identity, scope, status, and the schema definition. We have created schema in development mode, and it means we can update the schema. So to update the schema, you should send a request to the same URL and use put method. The body must contain the whole updated payload. The status 200 is returned and the schema is updated. Since I have the schema ID, I can retrieve it. As I said before, the ID is a sequence of authority, the source, the identity type, and finally, the version. So using this information, I can get the schema record. The response is the schema record definition. And the final example, if you don't specify the kind in the URL, you will get all the schemas available in the partition. So to reduce the number of return results, we use parameters. In the results, there is a list of schemas metadata.